Okay. In E-MOSFET DC biasing, again you will find voltage divider bias configuration. So remember that E-MOSFET used together with the feedback biasing configuration and also voltage divider configuration. Basically, the configuration same as the MOSFET, JFET or BJT, except the change of device to the E-MOSFET. Okay, all the calculation would be the same except for the transfer curve of E-MOSFET is different from those of D-MOSFET and JFET. Okay, we go to the example 9 where you determine the IDQ and VGSQ. Okay, this is the parameter, the VT, the voltage threshold voltage, ID on and VGS on. Okay, using the mathematical method, okay, draw the DC equivalent circuit, remove the capacitor and remove everything that is not related, and then find the equation, okay, the VGS. So again, we use voltage divider rule. Okay, divider rule. Okay, which is VTH, because voltage divider rule we get at this point, VTH, and for the voltage divider it say that this voltage is equal with the VG, because VG also measured from this point, right? So both are equal. Then we get the VTH. Okay, the VTH is stand for voltage divider. Okay, and then we get calculate here, VG is equal to 18 volt. Then we find the VS. VS is here. Okay, so ID, RS, equation, and then insert the RS, you get VS equal to 0.82 K ID. So the VGS now, equation is this, 18 minus 0.82 K ID. Okay, then we go to obtain the device equation. So calculate the K first. Okay, the formula for the K equal to ID on divide VGS on minus VT squared. And then we get 0.12 milli for the K. Insert this into the ID equation. And this is the VT. So, remember that, okay, we need to solve this equation to get the ID. And we get our VGS, okay, from the circuit equation. So you insert the VGS. Remember that the VGS is this one. VGS. Yes, the VGS is one. And then you calculate and you expand. Okay, from this one, final answer, you get this one. Okay, 80.69 ID squared minus 3.56 ID and plus 20.28 milli equal to 0. Okay, solve the equation using this formula. Okay, using this formula, and then I get ID is 37.4 milliampere and also 6.72. So due to E-MOSFET doesn't have limitation for saturation current IDSS, okay, the value of ID have to be checked with the circuit equation VGS to make sure which one is the true value of ID. Okay, again, use this equation VGS to calculate its value. Insert ID1 and ID2. For the ID1 here, so we get the VGS equal to negative 12.8 volt. Second ID, we get 12.49 volt. Okay, so we compare with the VT. Okay, with the VT, and VT is in positive. Okay, so we choose this value because this value is greater than VGS must greater than VT to make the transistor on. So we take this one as VGSQ. Okay. From the result, we conclude that the values of IDQ and VGS are 6.72 milliampere for IDQ and VGSQ is 12.49 volt. Okay. Next, use the graphical approach, okay, to confirm the value of the IDQ and VGSQ obtained from mathematical approach above. Okay, let's take a look for the graphical method. Here, we calculate the ID, okay, for the device here, and then use this equation to calculate each point. Find at least 5 points. Start with the VT. VT is 5, where there is no current, 0 here. Okay, and then take 10, calculate 10. Okay, VGS equal to 10, so ID we get 3. VGS equal to 15 here, so ID equal to 12. VGS equal to 20, we get ID equal to 27 milliampere. VGS equal to 25, then ID is 48 milliampere. VGS equal to 30, the ID is 75 milliampere. Then transfer this plot into the curve. Okay, plot the curve. So I get this point, this point. So you draw this curve. Okay. Alright. And then go back to the equation for the voltage divider, VGS. This one has been explained from the mathematical method, how we get the VGS, right? Means that, again, I repeat here, if VGS, we need find VG as VG minus VS. This VG is from the Thevenin. Yes, for the voltage divider, Thevenin, and then minus with VS. Okay, then you get this equation. Then we want to draw the straight line, so we need 2 points. So this equation is very easy. Okay, insert ID equal to 0, then you get VGS equal to 18. Insert VGS equal to 0, and you get ID is 21.95 milliampere. Okay, then you plot, okay, the point, the first point, and then the second point. Then you can make the line here. Okay, you see, this is the point, on the Q point, and there it is, the IDQ and VGSQ. This is the VGSQ and the IDQ. Okay, so we get IDQ is 6.7 milliampere and VGSQ is 12.5 volt. Okay, that's all the example for the E-MOSFET, where we have feedback biasing and also voltage divider bias configuration.